Hi everyone. In this video, I'd like to talk about input files. We've talked about interactive programs before in a previous video, which reads input from the console. So basically, while the program runs, it asks the user to type input, and then the input typed by the user is stored in variables in the code. The object that we used to get that input was a scanner, and a scanner can actually read input from many sources. It uses something called system.in, but besides having a user type things in, you can also read from files, websites, and databases. So just to remind you what scanner looked like before when we were taking in keyboard input, we created a new scanner by having new scanner, and then in parentheses we put system.in, and then we were able to store the input from the user. You could use things like next int or next line, whatever was appropriate here to get user input. And you could continue on using that same stream from scanner and keep using that same scanner object to keep reading input from the keyboard. And then since we're saving all of these variables, we use the stored variable and we do something with it. Cool. So when we saw scanner input is equal to new scanner system.in, we know that we're saving the name of the scanner to be input. It's a variable that is referring to a scanner object. So I called it input in this case, but you can call it any variable name you like. Scanner with the parentheses is what's called a constructor that sets up the object, and system.in is an object in the system class that refers to the standard input stream, which is going to be the keyboard. So this is the user typing in into the console. In contrast, doing file input is what we're talking about today. And the nice thing about it is using files allow for persistent data. Now, by persistent, I mean that data can be carried over every time you load a program. So it allows the user to pick up where they left off. So rather than having to rerun that program and the user is going to type in new things, starting afresh every time, now we can save data from different runs. The classical example of why you would want to have this would be in a video game. So for example, if you have different save slots for your game, you would be able to reopen that game and click on the save slot that you wanted and reload that game. And that's a pretty complicated file, but you're able to pick up where you left off without having to play the game through every single time. To be able to read a file into your program, you need to know where the file location is. There's a concept of absolute file paths, which is explicitly where something appears on the computer. And generally on Windows, you have this C at the top and you use backslashes, whereas on a Mac or Linux, you're normally going to have this like /, and it's normally users. You can also see like USR. It depends on the particular computer that you have a little bit, but these are some general rules that you might see. Now, you can also reference paths by relative names, and relative means relative to where the main program is running. So if you use command prompt style commands, you can reference anything relative to the program. So the double dot here means go up a level from where I am, and that will look at the folder that you're in and then look at any other folder that's below it or directory if you like. Or if there is a folder that's in the same directory, I use folder and directory interchangeably, then you can refer to it directly, or you can use dot. So let's just visualize this a little bit more so that we really understand what's going on with the file locations. So a good way to imagine where you are in a file system is, of course, with a tree. So at the very top, I have what's called the root, and that was with the /. Generally, that's what Mac and Linux looks like. Obviously, Windows looks a little bit different, So this looks a little bit different depending on what kind of computer you have, but nonetheless, all computers have a file system hierarchy. And let's imagine in this example, I have 3 different users on this computer. If you are in a certain directory, let's say that you are currently located here, you can always use relative file paths, right? So the dot dot to go up a file level. Well, that's what this would do. You can do it a couple times if you need to. And then you can, for example, go into another folder from there. So remembering relative file paths is really helpful depending on where you're running a program from. Although you can also, of course, use absolute file paths. So in this case, it was, since I wanted to just go here, these 2 commands end up being the same thing. So normally, of course, you're going to have some sort of Java file or some sort of program that you're running that's going to live inside some sort of folder, and you can have folders or directories underneath that. So given any file, you can reference another file by using the direct reference, because in this case, this folder is inside. If our program is inside of its own folder, you can again use the dot dot to go up a level and then go inside to see another file. So I guess I really want to emphasize that dot dot tells you to go up a directory, and then using the / you can go down into any other directory. Good. So a couple examples with that, and that hopefully is becoming more apparent that we use that both in the console, like when we're in the terminal, and we can use it from inside a Java program. So today, what we're going to see once we talk about Scanner a little bit more and how to read in files, we're going to use something very similar to how you've been moving around in the terminal before. Okay, so let's start talking about the file input stream class. The file input stream class creates a connection between our Java program and a specified file. And we're going to save these files as strings. For example, let's say that we have a file name and it's called alice.txt. So now I'm in a Java program. I'm going to create a new file input stream object. File input stream is equal to new file input stream, and in the parentheses I have the file name. Okay, so I saved that variable alice.txt as file name, and now I can create a file input stream object that refers directly to that file. So basically we've opened that so-called connection between the file that we want to read from and attached it to our Java program. And now we need a scanner. So scanner is going to take in this input. You create a new scanner, right, object as we have done before. And in this case, it's going to read in from file input stream, right? And it's usually best to do this in 3 separate lines so we can really see what's going on. I have my file input stream, and I have my scanner. You can, of course, put this all in one line if you so desire, but it's not quite as easy to read. And so another thing I want to point out here is previously we've been using scanner for keyboard inputs, as I pointed out earlier. So that was doing system.in. And now, rather than doing that, we are using a file input stream. So it knows that it wants to read it from a particular file. So let's look at an example that has a little bit more worked out code for you. So here I have file input stream, and I've called this new object input stream. And I'm going to read in some file called testfile.txt. Then I'm going to create a new scanner object, And now I have a while loop. While this input.hasNext, keep reading the file and then print it to the terminal. So let's take a look at how this might run. And I tried to compile and run it, but it turns out it's going to have a compile error, which is called file not found exception. So right here, it's saying for some reason, file not found. Okay, let's say I've done my relative and absolute file paths correctly, like test file is really there. There's one more thing we have to be cognizant of. It turns out that we have to throw a file not found exception. And you also, additionally, to be able to do this, have to import java.io.filenotfoundException. And once I add this in, things will work as expected. So let's say that my test file looks like this. I just have one line in there. It just says something goes here. And I know because of my while loop, it's going to just read the next input separated by white space and then print on new lines, something goes here, right? I'll talk more about what needs to happen with this file not found exception in a different video, but for now, we're understanding how to read in files to the Java programs that we're writing and be able to manipulate them in different ways. So the last thing I want to leave you with is just what you would do in general with this kind of token-based processing. Since we have a scanner, we use token-based processing to process the file input token by token. And for us, tokens are going to mean that it's separated by white space. So when I had that example of the sentence or the phrase, something goes here, that each word was separated by a space, which is considered white space, and that's why input.next was taking each of those words separately. So we use the scanner methods to do that, and in general we use next, which we saw, and you can keep checking to see if there are more inputs in that file using hasNext. Similarly, we can use nextInt and hasNextInt in the case where we know we're reading a number from the file. Next double and hasNext double similarly to reading an int. And since we don't necessarily know how long a file might be, we can use while loops to process the contents until we're done. And you can use for loops if you do know how long a file is ahead of time. So we can think about rewriting that example using nextInt and hasNextInt, or even rewriting it with a for loop. So I recommend doing that as an exercise to see what will happen. Right? So that's all I have for now. Thanks for watching.